You probably have experience saving changes with git add and git commit commands. But have you ever wondered how Git actually saves different versions of your files? Does it save only the differences between each version, or does it save a completely new version? Watch this video to find out. Now, to explain how Git actually saves different versions of our files, we're gonna consider the following project. It's called Alex's book. So it's about our writer Alex, who basically has 3 files: ideas, chapter 1 and chapter 2. And so far, she has made 3 commits. And here is the tree of the third commit. So tree, just to remind you, is basically a mapping that maps the file names. So for example, chapter 1 to its version, to its hash ID, ideas to its version, and chapters, which itself is a subfolder and it has its own hash ID. So it's itself, the chapters is of type tree. And inside the chapters, we have the mapping that maps basically chapter 2 to its version or to its blob ID. So you can think of the tree object in Git similar to what you have as a folder in your file system. It basically maps file names to their versions or to their blob IDs. All right, this is the tree that Alex has saved in her third commit. But in the meanwhile, she has been working on chapter 1 and she has some updates on chapter 1. So she has modified this file and now she wants to save the changes. So again, this is what we have, the current or the tree from the third commit, what we have already saved. And she wants to save the new version of chapter 1 because she has some new updates. So what she does is she types git add chapter 1.txt, and what happens is that Git does 2 things. First, Git creates a new blob based on the content of the chapter 1.txt. So based on the new content that we have now, the updated version, Git creates a completely different blob, and then it updates the index, or also called the staging area, with this file name. But what does updating the index with this file name mean? Basically what happens is that Git starts from the previous commit tree, so this tree that we have, and it goes through the file names in this index, and it basically updates those entries. So for example, in this case, we only have added one file, chapter 1, and what happens that Git updates the tree such that it creates a new tree. So you see this is a new tree than this tree, but the only change is that Git has updated file name chapter 1 such that now it points to a different blob, to this blob, while in the third commit, chapter 1 was pointing to this version or this blob of chapter 1. So even though we only use git add chapter 1 to update the mapping for chapter 1 in our index or in our tree, but basically for other files such as ideas or chapter 2, we don't need to add them because Git will already copy them from the previous commit. So Git will copy the whole tree from the previous commit and then will only update the files that we have added to our staging area. So in this case, chapter 1 was modified, so it updates it. But even if we have a new file here, then Git will add a new entry to our tree with that file and its new blob ID. And finally, when we use git commit, so remember now this is our updated tree in our staging area or index, and when we type git commit, basically Git saves a permanent record of this tree. All right, enough with the slideshow. Let's see this in action. All right, I'm inside the project of Alex's book and we have these files. First, I want to show you the content of the latest tree that we have from our third commit. For this, I will use git log to get the hash ID of the commits. You can see we have 3 commits, second commit and third commit. All I need is to copy the hash ID of the commit so that I can use the command git cat file with -p and I can look at what is inside the third commit. And here we are, we see what is inside the commit, the tree that it's pointing to, the commit message. Here I just need to copy the hash ID of the tree, and then I will use git cat file -p to look at the tree. This is all I wanted to see. So here is our table of contents, so to speak. So our tree from the latest snapshot from the third commit. Now there is an easier way to look at the tree if we have the commit ID. I'm gonna just clear and use git log again. This time I'm just gonna copy the commit, and using git ls3 I can just directly provide the hash of the commit, and it will show me the content of the tree that this commit points to. So here we see we have the same tree. So this is the tree from the third commit. Now, as we mentioned, Alex has new changes for chapter 1. Let's include those changes. So I'm going to clear again. I'm going to use, so we have the directory. Now we have new changes for chapter 1. I'm going to use nano to open chapter 1 and add these changes. So I'm just gonna remove this and copy paste the following work, and I will save it. All right, let's take a look at chapter 1 again, and we see that this line basically is the change that we have. Now, so far we have only changes in our working directory, meaning that we have not added these changes to our staging area. And we can confirm this with using git status command. And here we see that Git is telling us we have modifications on chapter 1 file, but nothing, no changes has been staged for the commit. Now here, before we use git add to stage our changes, I just want to show you that the current tree in the staging area is the exact copy of the tree that we have from the previous commit. So we can look at it using git ls files command, and then we can use a stage, and here we see the mapping for all of the files. So we see chapter 1 is mapped to this blob id, ideas is to this blob id, and if you remember, these are exactly the same from what we had. So from here you see what I showed already. We had this b08 for chapter 1 and so on. All right, so far we looked at the content of the tree from our latest snapshot from commit 3, as well as from our staging area, which we are seeing here, before adding anything to our staging area. Now we're gonna add some files to staging area, namely chapter 1. So we're gonna use git add, and then we can give the name to add this file to the staging area. Now if we use git status, you will see a different status this time. This time you see changes to be committed. We have chapter 1, and this shows that we have this in the staging area. Now let's take a look at the same command, git ls files stage, to see what has changed. So let's do git ls files -- stage again, and here we have the mapping, or the tree that we have in our index or staging area. So we see that for the ideas, we have the same blob ID. If I can show you, this is exactly the same. For chapters 2, again, we have the same thing because we did not change any of these files. But since we changed chapter 1 and also added this to the staging area, now the tree in the staging area has a new mapping. You see that this chapter 1 now is mapped to a different blob ID, which starts from 71.4. So this is a different version of the content of chapter 1, while it used to be mapped to another or different blob. So I'm just going to also show you what these blobs contain. So I'm just going to copy this from the third commit, and I'm going to use git cat file with -p and then enter, and you see this is the content of chapter.1 file in our latest snapshot that we saved in commit 3. And now if we look at git file -p from our staging area, so I'm gonna copy this. So because in the staging area we have this mapping, I'm just gonna copy this blob ID of chapter 1, and if I hit enter, we see that we have a new version, and the difference is that we have a new sentence basically. All right, so we see that our staging area, because we added changes for chapter 1, has changed, and the tree has changed, and the only change is the mapping for chapter 1. All right, so far so good. And now the only thing remaining is to basically save this new tree in our staging area permanently, and we can do it by using git commit. I'm gonna give a message: improve the opening of chapter 1, and hit enter. All right, so you can ignore Git complaining about setting the email and the user, but basically we did our commit, and I can show you. I'm gonna clear this, and I'm gonna use git log to show you the fourth commit that we just made. And here we go, we have our latest commit. And if we look at the tree that we saved in the latest commit versus commit 3, the only difference that we will see is the mapping for chapter 1. Let's quickly confirm this. So if we do git ls tree and provide the latest commit, so this is the latest snapshot, the tree in the latest snapshot. And now I will copy the commit ID from the third commit, and then I will do again git ls tree, and I'm now looking at the tree of the third commit, and here we are. You see that these two are exactly the same because we did not change ideas or chapters subfolder. The only thing we changed and we saved was chapter 1, and you see that we have a different blob ID. All right, I hope that you could follow up with this video, and you could see yourself by going through these commands to see when you have a change and when you update your staging area. It basically means that Git will update the tree from the previous commit, and it will, in this example, it only updated, we only updated one file, so Git only updated one, and that the differences between working directory, staging area, and the repository is more clear to you now. See you in the next video.